Okay, now let's look at solving some trig problems. And I'm really going to emphasize for these problems using the unit circle because it really makes solving these problems so much easier. So really this is going to be a talk about really using the unit circle and how it makes finding out the things we're asked so much easier. So I'm going to go down through a long list of problems like this. And here's the basic instructions. Find the exact value of, and then I'm just going to go down through a long list. First one, and you notice these are all going to be, the angles are going to be in radians because now we really need to start using radians, and it's very common to use radians when we're talking about trig problems. Sine of pi over 4. Now if you convert that to degrees, that's 45 degrees, but we don't really want to work with degrees now. We want to think in terms of radians. So basically they're asking what is the sine of pi over 4? This is where the unit circle becomes really, really helpful. The idea of the unit circle is in the first quadrant of the unit circle, let me just try and draw it. There are really three key values. Right here in the middle, well, let's look first here. We start here, the angle here is 0. The angle up here at the top is pi over 2, or 90 degrees, but now we want to think of radians, pi over 2. So now if we split this right in half, half of pi over 2 is pi over 4, and then it turns out the other two angles that they like to use a lot that we need to know, pi over 6 and pi over 3. So these are really, I guess there are really 5 angles there. 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now the thing about the unit circle is, for each of these, where these angles intercept my circle, I have an x and y coordinate. So for down here, when the angle is 0, this point right here, since it's a unit circle, this point here is 0, 1. Whoops. Sorry. 1, 0. X is 1, y is 0. There's x, and there's my y coordinate. Up at the top, that point there is 0, 1. Now here's the thing about the unit circle. If you're ever asked to find the sine or the cosine of an angle, you simply go to that point on the unit circle, and the cosine is whatever the x value is, and the sine is whatever the y value is. So if they were to ask me, what is the cosine of 0? Well, the angle 0 is right here. The cosine is simply my x value. And if they said, what's the sine of 0? The angle 0 is right here. The sine is the y value of this point, and it's 0. If I were to go to pi over 2, and someone says, what is the cosine of pi over 2? I go to pi over 2 on my unit circle, and if I want the cosine, I then say for this point, what is the value of x? Turns out it's 0. And if someone says, how about the sine of pi over 2? Once again, I go to this point. This is pi over 2. And for the sine, I look at the value of y at that point, and the value of y is 1. So that's the principle of the unit circle. And as it turns out, these other 3 points are the key angles. Now we need to know what the coordinates are for each of these points. So for pi over 6, the x is square root of 3 over 2, and the y is 1/2. So if you're ever asked for the cosine of pi over 6, you go here, you go grab the x value, say square root of 3 over 2. If you're asked for the sine of pi over 6, you go here. Since it's sine, I go get the y value, and I say the sine of pi over 6 is 1/2. Pi over 4, both the x and the y are the same. They're both square root of 2 over 2. So it turns out the cosine of pi over 4 and the sine of pi over 4 are the same thing, square root of 2 over 2. Now if I go to pi over 3, what's nice is it's the same thing as pi over 6, but just the x and y are flipped. So when I go up here, now my x, or my cosine, is 1/2, and the y, or the sine, is square root of 3 over 2. So now back to my original problem. Let me write it here. I'm asked, what is the sine of pi over 4? What I do in my head is I go on my unit circle and I go find out where pi over 4 is. And in my head, I realize, okay, pi over 4 is that point right here in the middle of this first quadrant. And then I say, okay, since I'm looking for the sine, I need the y value of that point. Well, as it turns out, pi over 4, the x and the y are the same, and they're both square root of 2 over 2. So I right away was able to get the value of the sine of pi over 4. Then they say, what is the cosine of pi over 3? So in my mind, I'm going to go find pi over 3 on my unit circle. And when I find that point, I'm going to look at what the x value is. Well, pi over 3 is right here. Turns out the x value is 1/2. So the cosine of pi over 3 is 1/2. Let's just do one more. How about if they say, what was the sine of pi over 6? So I find my pi over 6 point on my unit circle. Since I want the sine, I'm looking for the y value. At pi over 6, the y value is 1/2. So sine of pi over 6 is 1/2. Now these 3 examples were all in the first quadrant. What we have to do is we have to be able to determine the trig functions for all the different angles. But the nice thing is, these 3 angles sort of repeat themselves all the way around the circle. The only thing that changes are the signs. I don't have time now to draw this out, but let me do some problems. And I've got a unit circle chart here, which I'll refer to help you understand how you find the rest of these. So for instance, how about if someone says, what is the cosine of 7 pi over 4? I have to be able to, in my mind, go find out where 7 pi over 4 is on my unit circle. And then once I find that point, I have to go remember what the x coordinate is. Now 7 pi over 4, if you think about it, the whole circle is 2 pi. 7 pi over 4 is very, very close to 2 pi. So that means I'm going to be in my 4th quadrant. So 7 pi over 4, when the denominator is 4, those are always the halfway points of each quadrant. So if I look at this chart right here, hopefully you can see it. Look down here, here's 7.4. It's like the midway point of my fourth quadrant. And the nice thing is, all the points with the denominator 4, the x and y are the same. They're all square root of 2 over 2. The only thing that's different is the sign. So since this problem asks for the cosine, I'm going to go with the value of x, and it's square root of 2 over 2. So almost right away, I know that the cosine is 7 power 4 square root of 2 over 2. How about the sine of 4 pi over 3? If I look back at that first quadrant, my pi over 3 point was here. So I go to my unit circle, and once again, you need to sort of have this in your head. But I know 4 pi over 3 is just a little bit past pi. Pi is on the left-hand side of my chart. So I go here, and look, 4 pi over 3 is down here in my third quadrant. And since I'm asking for the sine, I'm looking at the y value. I know the third quadrant, y value is negative. So the sine is negative square root of 3 over 2. So all these angles they give you are going to be on the unit circle, and it's just a matter of finding them. How about another one? Cosine 11 pi over 6. Cosine of 11 pi over 6 is almost 2 pi. So we almost go all the way around the circle. If I look at my unit circle, here's 11 pi over 6. So I'm at this point right here. Since I'm asking for the cosine, I go get the x value, square root of 3 over 2. How about if they say tangent of pi over 6? Well, basically, what I do is, since I know the tangent is the sine over the cosine, I go to my unit circle at pi over 6, and I write down what the sine is, which is going to be the value of y, and I divide it by the cosine of that point, which is the value of x. So if I go my unit circle to pi over 6 is in the first quadrant. It's right here. And basically I'm going to have x over y. So I have 1/2 over square root of 3 over 2. So the sine of pi over 6 is 1/2. The cosine of pi over 6 is square root of 3 over 2. If we do a little bit of math here, turns out the tangent of pi over 6 is 1 over square root of 3. So that's the idea of using the unit circle. And where the unit circle really comes in handy is sometimes you get larger angles. For instance, here's a simple one. What's the sine of pi? On the unit circle, pi is like the negative x-axis. So what's the sine of pi? It's the y value, which is 0. But here's what they're going to do. Sometimes they'll say the sine of 4 pi. Well, the sine of 4 pi means your angle is 4 pi. When you think about your unit circle, we know one trip all the way around the unit circle is 2 pi. So what would 4 pi be? 2 trips around the unit circle. Where do I end up at? I end up back right here at 0 or 2 pi. So what's the sign of that point? Well, the y value at that point is simply 0. How about another one? How about the cosine 5 pi. So if my angle is 5 pi, where do I end up? That means I go around the unit circle twice. That's 4 pi. And then I have to go 1 more pi, which means I end up over here. Now the cosine of this point, or the x value, is -1. All right, so that's the power of the unit circle. It takes a little bit of effort to memorize it, but once you've got it down, it makes doing all these kinds of problems very, very simple.